Okay, so we're skipping ahead a little bit to frequency conversion. So this will change the frequency of our data set. So we're going to have a date range from January 1st, 2010. There'll be 3 periods with a frequency of 3 business days. So we have 3 business days here. But we can convert that to business day, so every business day frequency, by using this asFreq function and then passing what we want to change the frequency to. Now, by default, we'll just fill these with nans, which are not a number, so it's just there's nothing there. But if we want to use method equals pad, this will fill forward. So, and also I'm using this alternate syntax of, so when we type capital B in quotes, that's shorthand for this particular class, which is a business day offset. So when we do that, we fill forward, so we're going to get the same value until we get to the next day. Alternatively, we can use this really handy function, which is fill NA, which will take all the NA values and fill them with whatever we want. So let's say we want those to be zeros instead of numbers, or instead of instead of filling forward, we can fill with zeros. Okay, so most of what we've covered so far has been date-time objects or timestamps or date-time indexes, which are arrays of timestamps, and those indexes can have frequencies associated with them, but they are still discrete points in time. However, sometimes it makes more sense to consider a period instead of a single point in time. So for example, we can use this pandas period to convert 2012, the string 2012, to a year, which is we use A, and by default the year ends in December, which has some implications for how it's handled. So we can also specify a day, or an hour, or 5H would be frequency every 5 hours. And so we can get some interesting behavior now of these. So if we have a period that's 2012, it's the year 2012. If we add 1 to it, it's going to add 1 year to it. So now it's going to be 2013. Or we can subtract 3 from it. That will subtract 3 years from it. So it understands that this has this particular behavior. This has to do with the dynamic typing of Python, right? So p minus 3 if p was an integer, it would give us an integer, because p is a period of frequency year. It gives us a year. So if we have period January 2012 with frequency 2m, and we add 2 to it, that's going to add 2 months twice, so we'll add 4 months. Similarly, if we subtract 1, it'll give us 2 months in the past. So we can add offsets of hours, or minutes, or seconds, and it will preserve the frequency that we provided. So here we're going from, we're taking July 2014 as a month, adding 3 months to it, or 2012 minus 2002. So there's some interesting differences. So if we take two timestamps, so let's say we want to know how much time has passed since January 1st, 1970, when we started doing, using this epoch-based timing. So we have the special function called pd.datetime.today. This will give us the exact time right now. And then we subtract from that this timestamp of January 1st, 1970. So this will give us 17,589 days, 10 hours, 16 minutes, 22 seconds, because it's 10:16 a.m. right now. So there's no time zone associated with it. We'll cover time zone in a minute. If we instead render these as periods, so we're going to say today as a day and January 1st, 1970 as a day, it will give us the answer in days. So it will understand that we're comparing these two periods and not these nanoseconds. Similarly, if we do the same thing, but instead we render it in years, it will give us the answer in years. So this is kind of a cool feature, and we could also have gotten that information by for example, let me see if this works. Right, so we could have gotten that information from the first way, but we can use this attribute to just get the number of days, or let's see if that works. No. So just like we have date range index, we have period range index. We can have we can use this period range function. It creates this period index object, which has a certain frequency. We can also use this constructor directly, or have a start, frequency, and number of periods, just like with the date time index. So we can have a different, a frequency in hours, for example. We can use offsets. And similarly, it will infer, the index from a string. It will try to parse it and generate it that way. So I want to make sure we cover time zones because that's really important. So a lot of the same functions with periods are the same as with timestamps. It just handles it, a little differently. Okay.